to, yeah, pleasure. So now we're moving to a tech talk by Sunayana Sitaram. And she's a senior researcher at Microsoft Research India, where she works on speech and natural language processing. Currently, the focus of her work is on the evaluation of massive language models, multilingual speech and NLP, and code switching. She has organized various special sessions and workshops on multilingual speech and NLP across the world and has served as a reviewer and area chair at the top NLP and speech conferences. Her research goal is to make all the content in the world available to all the people in the world, regardless of the language they speak, their demographics, and their special needs. Sunayana holds a PhD from the Language Technologies Institute, Carnegie Mellon University. Sunayana.
Thank you so much.
That's her. Sure. The field of NLP relies on standard metrics and benchmarks for automatic evaluation of models to get an accurate estimate of how systems will perform in the real world. Recently, transformer-based techniques have revolutionized the field of NLP by making great progress on these benchmarks. However, these models have been shown to be brittle, unreliable, and make serious errors when used in the real world, indicating the limitations of current evaluation strategies. Benchmarks are expensive to build and lack linguistic diversity and coverage. This widens the gap between languages that can and cannot be served by language technologies today. In this talk, she'll highlight the limitations of current NLP evaluation techniques and discuss the directions to scale up evaluation, which can help the field move towards building accurate, usable, and equitable technologies for all. So, Dina.
Thanks so much. And thank you for the invitation to speak here. I'm really glad to be here. So, as Radhika mentioned, I'm from Microsoft Research Lab, and this is one of the 8 or 9 now research labs across the world that Microsoft has. So we have one here in Level 2. And the focus of my work is on NLP and speech. And recently, for those of you who work with NLP or use these kinds of models, you may have seen that there are, yeah, sure, yeah. Is it okay now? Yeah. All right. So you may have seen that there's been a paradigm shift in the way NLP is done now with the rise of so-called large language models or massive language models, where the idea is that you build one model and then you reuse it for various tasks and applications by doing some sort of training over it, right? And this has led to a lot of headlines on the newspaper. Is it switched off? Okay. Yeah, yes. All right. So you may have heard, you may have read things like this, in news articles where, NLP is seen as the solution to lots and lots of problems in different domains. Models are getting better and better. So you see these all the time, like they're releasing huger models that are doing really well on these benchmarks. And there's this notion of being as good as humans, right? That is called human parity that we have reached in some of these tasks. And a lot of this is driven by performance on these benchmarks. And what are these benchmarks? These benchmarks are basically evaluation sets or test sets. And some of them cover a variety of tasks and languages. And the idea is if the model does well on these, then it's solved the problem. Right, but there's a little more to that, and that is what we try to dig a little deeper. Being people who create this technology, use this technology, we want to really make sure that the claims we are making are actually valid, right? So there's lots of great things about these benchmarks, and really they're the backbone on which the field is right now today. So what are these benchmarks used for? They're used for model optimization. So the model is trying to do very well on these benchmarks. So you use it in your learning objective in order to make the model better at it, right? It's also used for, of course, evaluation of models. So you're trying to see how good your model is by using these benchmarks. If you have multiple models and you want to figure out which one of them is the best, which one you want to deploy, say, you may use the scores that those models get on the benchmark and then pick the best one. Right? You may also use these benchmarks to enable new capabilities. So if you find that your model is doing poorly on one part or one subset of the benchmark or one task on the benchmark, you may go and train it in a different way and enable it to be capable of solving that particular problem, right? Benchmarks are also used to measure field-wide progress. So as you saw in the human parity examples, right, now we feel that we have come to a certain stage, the field has come to a certain stage for, say, speech recognition or machine translation in some languages where we're doing as well as humans are on those tasks. And of course, for scientific inquiry to figure out whether these models are capable of doing certain things like understanding language and so on, right? So it's great. Benchmarks help us do all of these things. But unfortunately, they also come with their own set of drawbacks. And what are these drawbacks? So it turns out that the entire field tends to over optimize on a small set of benchmarks, right? And when you do that, you end up actually doing really well on that particular benchmark, but not necessarily doing much better on the task itself. And there is a big difference between those two. There's also a conflation of benchmarks with domains or with tasks. So just because a model does well on a particular narrow task doesn't mean that it knows how to generally translate data or understand language. And there is a distinction here that we need to be very careful when we market our work. When we use benchmarks for selecting models, if the benchmark itself is biased, then we may be actually selecting a biased model. And there's also a conflation of benchmark performance with actual capabilities. Just because the model is able to do better on a particular capability that the benchmark has doesn't mean that it has learned how to solve that capability in general. Again, benchmark improvements don't necessarily mean progress because of all of these reasons. And all of this can lead to a lot of hype about what these models can actually achieve and not achieve. And there is a law called Stratton's law, which basically says that when a measure becomes a target, it ceases to be a good measure, right? And so while it's wonderful that we do have access to all of these benchmarks, we should make sure that we are not over relying on them and making them like the be all and end all goal of our research and our work. So we did a little more digging into what these benchmarks look like. Since we work on multilingual language technologies, we are really interested in what kind of coverage these benchmarks have. So this is from a recent paper that we wrote, where we looked at what are the different kinds of tasks that these benchmarks cover. So by task, I mean one task could be sentiment analysis, another could be question answering, and so on. So these are different NLP tasks. And typically these benchmarks try to cover multiple tasks so that they can, if a model does well on all of them, then you can make statements about the model being good in general, right? So we found that while it's true that the number of tasks are increasing, so this whole field kind of took off around 2015, and we're finding that every year people put out new benchmarks with different diverse tasks. We find that unfortunately the number of languages that these benchmarks cover are quite few. So on the y-axis on that plot, you can see the number of tasks, and on the x-axis, you can see the number of languages. And these massive multilingual models, so these are things like multilingual BERT, XLM Roberta, and our own internal Turing models, they support around 100 languages. These are languages that are typically found on Wikipedia. And theoretically, these models are capable of being used for any of these 100 languages through things like zero-shot transfer and so on. So ideally, these benchmarks should actually cover all of the 100 languages if we want to make statements about the model being good across all languages that it supports. Unfortunately, we find that only one or two tasks actually cover all the 100 languages. And the way that these benchmarks are created are also not ideal. They are through translation and so on. There are only around, say, 15 or so tasks that actually cover 10 languages in the world, right? And what do these 10 languages look like? Right? Which are these 10 languages that these benchmarks would cover? So we did a classification of languages according to the resources that they have. These resources are labeled and unlabeled data. And we classify languages into 6 different buckets, class 0 to 5. And we find that most of these benchmarks only end up covering high resource languages. And you can see which high resource languages they are. I can read them out to you. So English, German, Chinese, Russian, Spanish, Arabic, and so on. So most of these benchmarks focus on these high resource languages for which there's already a lot of attention paid in the field. And all the other languages that the field doesn't really pay attention to are ignored even by the benchmarks. So again, given how important these benchmarks are in NLP and how these models are being optimized on these benchmarks and how we are making statements about how good these models are, the fact that many of these languages don't even exist in these benchmarks is quite problematic. We again did some more studies to see which kinds of languages, so which language families are covered in these benchmarks. And what we found was that so you can divide languages of the world by family according to how they came into the world. And so you have like the Indo-European languages, which are like the Indian languages, and also some of the others like Sino-Tibetan and African and so on. And we find that there is an extreme bias towards the Indo-European languages in these benchmarks, because as you can tell, they cover English, the European languages, and some of the Indian languages. Right? So the other languages like the Afro-Asiatic languages, the Sino-Tibetan languages, some of the languages of Papua New Guinea and so on, those are not covered in any of these benchmarks. And again, so making very generalized statements about how these models are doing very well on certain tasks doesn't take into account anything at all about performance on these languages. So now what can we do, right? So we are at a stage now where we know that the current benchmarks are very limited, and ideal solution is of course to build benchmarks in all languages for all tasks, right? So you have to build separate test sets for different tasks. So your sentiment analysis benchmark, if you build it for Kannada, it's not going to be useful for, say, question answering, right? So because these are different tasks and models perform differently on different tasks. So what do you do, right? Benchmark creation is very expensive, given that some of these languages may not bring in a lot of money. People may not be willing to invest the effort to collect label data. This is all label data for all of these languages, for all of the tasks. And beyond a point, it also becomes like an intractable problem. So then, do we just stay where we are, or do we try to do something, right? So what we're trying to do is called performance prediction. And this is something that a couple of research groups in the world have started looking into, where in the absence of a test set in a particular language, can you still get some sort of idea about how the model is going to perform on that language, right? So that's called the performance prediction problem. And here the idea is that you know what kinds of factors influence performance of these models on different languages and tasks. You also know something about languages itself, like linguistic features, how languages relate to each other, what are the different features that are useful for different tasks, and so on. And then you use all of this information, given that you already know how well your model is performing on a task on a set of languages that you already have the data or the benchmark for. Can you extrapolate this performance on the other languages too? Right? So that's the problem that we pose as performance prediction. And this has gained some traction. We are actually organizing a workshop on this at IJC NLP later this year with professors from CMU and GMU. And there are a couple of research groups in Cambridge and CMU that are also actively looking into this problem, because we feel like this kind of approach is better than doing nothing. It doesn't replace building actual benchmarks for all these languages, but since we know that that is infeasible for now, at least we do this and make sure that all models go through at least this performance prediction to make sure that we are doing reasonably well on all languages. So what's the performance prediction problem? So essentially what you're given is you're given training data of runs of your model on languages that you already have the data for. So you have, say, 10 languages for which you have a benchmark. Maybe these are all the Indo-European high resource languages. And then you use this data and you use all of these different features to build a regression model that will then predict the scores on all of your target languages, which may be any of those 100 languages that I mentioned that the model covers. So what kinds of features do we use here? So we use features that are related to the test language. So test language is your target language, the ones that you want to get the performance evaluation for. You also use features that are related to the training language. So you may have a model that you have trained, fine-tuned on some set of languages. So you use the features of that. You also use features that capture the relatedness between the training and the test languages. So there are features called linguistic typological features that cover this, that capture these kinds of relationships between languages, and also some features about the training data set as well. So we also use features like data size and what the other linguistic features of the data itself are, in addition to the language itself. So we use all of this, create a regression model, and I'll just quickly go over the tool that we built that does this for you. So this is called the Litmus Predictor tool. And we have a bunch of papers at AAAI, NACL, ACL, etc., that go into the technical details. I won't go into too much today. What you can do with this tool, which is open sourced, is that you can tell it what the pre-trained model is. So your pre-trained model is your BERT or XLMR or whatever your large language model is. And then you can also tell it what the task is that you're trying to measure for. And if you want to do model comparison, you can have multiple model configurations that you add over there. So over here, if you look, you have three configs, config 1, config 2, and config 3. Now, config 1 says that I took my XLMR based model, and my task here is a sequence tagging task. And with config 1, I trained the model again, additionally, on 1500 Tamil data points. So that's my model 1. Okay. Now my model 2 is trained on 1700 Tamil and 1700 Japanese data points. My model 3 is trained on 1000 English data points, right? Now I want to use Litmus Predictor to tell me for my target languages, which are English, French, German, Tamil, Chinese, and Japanese. So these are the ones I want my predictions on. Which of these three models is going to do the best? Okay, and what are the scores going to be on these? Because I don't have evaluation data for these languages. There's some other data collection stuff also, which I'll get into. But for now, you can see on the right side. So let me just, yeah. So if you look at the heat map below, actually, it shows you the performance of these three models. So config 1, config 2, and config 3 on those 5 target languages that we specified over there. Red is bad and green is good. So can you guess which model is the best here? So it's the config 2 model, right? And if you just look at the config, like what the config 2 has, it has Tamil and Japanese data. And our test languages are English, French, German, Tamil, Chinese, and Japanese. So it's quite obvious that, if you train the model with Tamil and Japanese data, it's going to do well on those. But it's not necessarily the case that you have to have all the data in the training data in order to do well. There is also zero-shot transfer that happens across languages. So by looking at this now, without ever having evaluated your model on all of these 5 test sets, you can then choose which model you would like to deploy, say, because that seems to be the best one overall. Another thing that you can do, which is a very powerful feature, is you can also play around with the training configurations here. Even if you don't actually have Japanese data or you don't have Tamil data, you can see what happens if you would add it over there and see what the performance would be of your on your target languages. And this is what we use for a data collection strategy. So the problem here that we address, I'll just finish. The problem here we address is, okay, you've built your version 1 of your model. Now you want to make it better. You've got the predictions for whatever target languages you have. Now you want to make it better somehow. And say, your boss has said, okay, now you can go and collect 10,000 additional labeled data in order to make your model better across these 5 languages. How do you collect this 10,000 data? Now, which languages would you go and collect the data for? Would you divide them equally? So say 2,000 data points in each of those languages. Or do you want to, maybe it's easier to collect Tamil data and harder to collect Japanese data for some reason. And so you say, okay, no, I'll collect 3,000 points in Tamil and I'll collect 1,000 points in Japanese and then see what happens, right? So a lot of these decisions tend to be ad hoc, and we want to try and change that because we do have a predictor which will tell you, given a data configuration, how well your model is likely to perform. So that's what we do. So again, we ask you, what your budget is. So how many data points you are willing to label, and then what are the languages that you can collect the data in. And also you can add some other constraints like what is the minimum acceptable performance across those 5 languages that you want. And also if there are any costs associated with collecting data, etc. You can add all of this into the search algorithm. You can also specify which objective function you want to minimize. And then it will tell you, it will give you this data collection plan, which tells you, okay, for this configuration, for all the parameters that you care about, you should collect actually, 50% of your data should be French. You should collect 1/4 data Japanese, some Chinese data, and some English data, right? So this is the configuration it says, the data collection configuration it says, will give you some sort of, so a 6% gain in your overall accuracy over the languages that you care about based on all of the different parameters that you set. So we feel that this kind of tool should become part of the, the MLOps pipeline when you're building a multilingual model. Even if you eventually don't care about these 5 languages and you're not trying to actually deploy the model for, say, Tamil, even then, if you can at least check that your model is general enough that it does reasonably well across all languages. It has some minimum performance according to a predictor, and the predictor doesn't raise any red flags, then you can be reasonably confident that even though you haven't evaluated your model on all languages, it's a good multilingual model in general. Right? So that is the idea that we are pushing, because otherwise, right now the situation is that the testing is only done on a very small subset of languages before releasing the model and claiming that it is a multilingual model. So I'll quickly end with the takeaways. So as I mentioned, benchmarks today are the essential resource on which all of NLP and also other ML subfields like computer vision and so on, they also rely very heavily on these benchmarks. And there are very good things about these benchmarks, and they put everyone on a level playing field. It's very easy to compare results when we have a standard benchmark that the entire field follows. But then this also leads to some undesirable things like over optimizing on these benchmarks. And these current benchmarks are quite limited. So in terms of coverage, linguistic coverage and also domains and so on, there's also bias within the benchmarks. And if you're testing on a biased benchmark, then your model may be biased as well. These benchmarks are also static. They don't get better with time. So as we over optimize on these benchmarks, actually, one of the things that Professor Chris Potts talked about in the talk that I referenced is that the speed at which we are doing very well on the benchmarks is increasing. So earlier it used to take a few years for the community to reach this so-called human parity, but now within a few months you're able to reach that. And that's because we are able to put lots and lots of GPUs, do lots of hyperparameter searches and so on, and really optimize for that benchmark very quickly, right? But whether that means that we are actually getting better at the task, that's a question mark. So the idea we are pushing is that you have some sort of performance prediction as well, in addition to your benchmarks, which will give you a more general idea about whether your model is doing well or not. And it can be a way to scale up evaluations. And finally, as practitioners, as people who use these technologies and talk about these technologies, I think it's important to remember the hype around AI and benchmarks in general, that this kind of hype makes it difficult to measure real progress. It also makes it hard to use AI responsibly. We don't know where it should be used and where it shouldn't be used if we give in to the hype and plan for an equitable future. Thank you.
Hi, thank you for the presentation.
Sure.
So a couple of questions about the litmus predictor that you spoke about. So does it still, you said that the data requirement kind of goes down with this kind of a model. So does it like still split the data between testing and training or not? And the second is, you mentioned that you could tweak the parameters, and even if, let's say, you don't have data pertaining to a particular language in the training set, it could still show you how the model would perform on that language, right? How does that work? Because you don't have representative data.
Yes.
So how's the ME calculated? Because the heat map was based on that.
Yes. So for the calculations of the errors, we do use we use runs on the actual training data, because we need the test data, because we need that to compare the errors. But the litmus predictor itself is not reducing the data requirement of the model. So the predictor is a separate model from your NLP model. So the predictor is a regressor that is built on top of the scores that the NLP model generates on a task. So you have an NLP model that is giving you, say, 80 F1 score or 70 F1 score on a whole bunch of languages. So you have all these scores, you have all the languages for a particular task. Now you build a model that tries to figure out, for these languages, the model behaves in this way, right? And so given a new language, because we know how these languages interact with each other, what kinds of features they share, what kinds of features are represented in the training data. So there's a lot of sophisticated feature engineering that goes into this. Because we know that we are able to build this separate predictor that will give you an idea of how well your model will perform, your original NLP model will perform on a new language. So it's not reducing the data requirement other than the test data requirement of the model training itself. Yeah. So that was your first question. And your second question was about the parameters, right? So yeah, that's what. So for the actual error bars and so on, we need real training data to be able to estimate. Yeah.
But is that like an output? The ME is not an output from your litmus predictor?
It is if you have the data for that particular model. Yeah. Yeah. Yes.
Really cool talk. I mean,
Thank you.
sometimes I do wonder that, hyperparameter training that goes on a validation,
Yeah.
but the validation set actually becomes a training data set, literally.
Exactly. Right.
So I think what you have done is pretty innovative on that front.
Mhm.
The question that I have is, once you end up having this pseudo, I call this a pseudo metric function that you have,
Mhm.
what is to prevent people from gaming that and also
Absolutely.
optimizing their model to perform really well on this,
Yes.
so
Yes.
that you are once again disconnected with reality?
Right, right. So one of the things that we don't want our model to become is one more thing, that one more hoop that people have to jump over to be able to put their models in production, right? So when we envision our model to be in the AI pipeline, like the MLOps pipeline, we don't want it to be something everyone hates and has to get through. For that, actually, we have built a whole bunch of different models now. We have multitask models, we have models that cover different sets of languages and so on. And it's not a static thing, so we hope to keep it, like, keep evolving it. When we use it internally and people train their own regressor, so when you're doing it for a new task, you need to train a regressor that will work for your task. So we hope to integrate those trained models also into the general multitask model, which will keep making the predictor model itself stronger and stronger and stronger and evolve with time, hopefully. That's the plan. But I do agree that there is a chance that people start sort of doing whatever minimum requirement is there to make sure that Litmus doesn't flash red anywhere and just is green
Because you're
everywhere.
optimizing system.
Right. Yeah.
One thing we could look at is just what a cost to how many times you call your litmus itself.
Sure. Yeah.
If you evaluate too many times,
Yeah.
you end up literally training on the
Training on it. Yeah.
itself.
True. Very true. Yeah.
Hi, this was great. And
Thank you.
so one question, like you suggested that this can evaluate with the cases when you don't have any data.
Yes.
And I'm just assuming that if you get some language, let's say that language and the other language on which you are making the comparison, both has very different subject and predicate, relationship
Yes.
sort of setup.
Yeah.
How do you, calculate your features so that this is comparable enough? Because
Yeah.
language model essentially checks, their occurrences together and all.
Yes.
Because yeah.
Yes, you're very right. So all of these features like subject object and all of those typological features are there in our model. And there are some languages that don't have any features in common at all. So there are some, say, some of the African languages or so, which have no representation of those features in the among all of these languages which we
English
already
and all,
have the
yes.
training data for. So for that, actually, the answer to most of these kinds of problems right now that we have is to build a multitask predictor model. So our predictor model, the sort of the model that we start with, is actually trained on various tasks, various languages, as many tasks and languages that we have right now in the world. And that model is now being used to do the prediction for your specific task. So it has as much coverage as we can do right now, but there are still cases where there are some languages which have very few features and those get missed. So those will get so you will have a misprediction on those
So
kinds of
ideally, you have to
languages.
build those linguistic features separately, other than.
So the linguistic features themselves we have, because those are taken from these very comprehensive databases of. So for each language, we have the list of linguistic features that it already
Those
has.
are rule-based features, sort of.
Those are created by linguists. Yes, the features are created, but what we need is we need training data that has those features. So we need training data that is like the training data needs to represent those features. And even if it's there, say, your new language has 5 features, and you have three languages in the training set, and 2 from this, 1 from this, and 1 from this will make up the training data for that language. Will do the prediction for that language, basically. So that is the way we do the prediction, but there are still some languages that do get missed even in this setup. Yeah.
Thank you.
Welcome. Yeah.
Hey, hi. Amazing talk.
Thank you.
Really loved it. So I think my question is more on if you've got any interesting insights, because it's not common knowledge that Tamil and Japanese actually have similarity, but the linguists actually know it. Tamil and Korean also has it.
Right.
So is it like, do you also have some insights for practitioners, like saying, hey guys, we found this interesting stuff, like, comparing these languages seems to be,
Yeah.
maybe we can also use it, let's say, for example, for other tasks. if we have to work on it, right? Like rather
Yes.
than a multi-language model, but let's say something, if I were to work on only 3 or 4 languages,
Right.
which languages would work well?
Yes, so we definitely have some insight. So, I mean, these models are black boxes, as you all know, right? These BERT-like models, these huge language models, but these multilingual versions of them are even bigger black boxes, because now you have 100 languages embedded in the same space, and it's very hard to tell what's going on. One of the very sort of bad one of the bad things that happens is that sometimes when you train with additional data from one language, suddenly the performance on other languages tanks. And we are trying to figure out why. There's a lot of interference that happens between languages. And if you're not careful and if you don't do enough checks and balances, then you could be, again, because you're over optimizing on certain things, you could be putting out models that work unexpectedly badly for a language when they actually used to work well earlier. So some of the insights we've had are that in some cases we find that similar languages of course help each other. So if you train with say Hindi, then Urdu is going to get better probably. However, we find that there are interferences between say Hindi and Marathi, which is very unexpected. But then we find that things like the script being the same, the tokenizer that is used before processing and so on, those have a huge effect on the ultimate accuracy of the models. Tokenizer actually was a very surprising thing for us, but we found that the performance of the model is so correlated with the performance of the tokenizer for that language that just changing the tokenizer and making that more suited for a particular language, it leads to huge performance gains. So we do see some things like this, but I think we are far from actually understanding what's going on in these models more comprehensively.
Hello. Thanks for the nice talk. It was really knowledgeable for all of us.
Thank you.
Here, when we come to languages, we talk about language preservation, where there are people from all over the world, especially from the African subcontinent, who want to preserve their languages.
Right.
And even in India, we see, apart from the major languages that we see, there are a lot of smaller languages for which preservation is required. And they say that NLP is the future, right? So if we have NLP for a particular language, the chances that it will exist for many years to come is there. So how do these benchmarks affect language preservation? Does it help in language preservation?
Yeah. I would say, unfortunately, benchmarks and these large language models do the opposite right now. So they in fact widen the gap between the languages that have it and don't have it. Because now, in order to build even a simple system for a language, you need to run this huge giant model which requires GPUs. You need to collect a huge amount of data, etc., even to build the model, right? Whereas earlier that was not the case because we used to deal with simpler models. So unfortunately, these models and these kinds of things don't help in language preservation at all, I would say. But we are doing other things, and we believe very strongly that when we talk about language preservation, we need to go to the communities themselves and ask the communities what they want, like whether they want to preserve their language, what are the tools that they require in order to preserve the language. Sometimes it could be translation tools, sometimes it could be educational tools, sometimes it could be information access tools, and so on. So we work directly with the communities for this, and not on this Litmus project, but there is another project called Ellora, which Kalika Bali from MSR leads, where we are working with communities like the Idumishimi community in the Northeast, and also the Gondi community, which is actually a large population in Middle India. And we work with these communities to figure out how to preserve languages. But again, we take a very sort of bottom-up approach for this, and we don't assume anything from the top that these are the technologies that we need to do language preservation. But more efforts are needed in this direction, because otherwise we will be losing a lot of languages very quickly.
Thank you.
Welcome.
Hello. Hi.
Yes.
So, wonderful talk. Thank you so much for talking about the benchmarks and the biases they might bring in, because a lot of us evaluate our models on these benchmarks. And once I hit a benchmark, I'm like, okay, I'm very happy. Let's just move on with my life.
everybody does that. So, like we do that too. So yeah.
exactly.
Yeah.
So that's how we do it. But I also feel it's very important that we go beyond the benchmark.
Yeah.
I have two questions. The first one is around that pie chart that you showed. So, for example, if I get an output that I need 50% Japanese, 20% English, and 30% some other language,
Yeah.
do I need to feed the same corpus in different languages? Is that how I interpret that pie chart?
Yeah, that's a very good question. And the one of the assumptions we make when we are doing this prediction is that the distribution of the test data is the same as the training data, which is not always correct. So we can't say much about what the training data should look like, what the data that you actually collect should look like right now. But we are working on trying to give guarantees based on the distribution of data also. Like if you have this as training data and your test data looks like this, what is the prediction on this test data that you will get, this kind of test data that you will get, like this domain or this general distribution. So that is an unsolved problem as of now.
All right, thanks. I have one more question.
Mhm.
So I'll take an outside-in view about this thing because we do a lot of Kaggle competitions with NLI tasks.
Yeah.
So we did one recently, which was a multilingual natural language inferencing problem.
Right.
Now, one of the languages was Tamil. So of course, Roberta, XMLR, everything fails there. So how we go about that is we use either a pre-trained embedding or a translation service
Yeah.
to translate things as much as we can.
Yeah.
But the kind of problems that we run into is okay, so it has sand and it has which in the training data, and it encounters sandwich in the testing data, and you can see where it goes from there.
Yeah.
So, do these kind of benchmarks help me assess how that kind of model would work in practice?
Right now it wouldn't, but there is another problem that you're alluding to, I think, which is a bigger one, and that is just translating data doesn't always work. And for testing as well as for training. And for testing, it's actually a little, that is how all these most of these multilingual benchmarks are created. The ones that exist, the ones that cover 10 languages, etc. You take the English one and then you translate it into 10 languages. So now you have a multilingual benchmark, but that's not always ideal because it doesn't capture nuances like cultural nuances or specific things about geographical location, etc. That the, say, a question answering system in Tamil should know something about the Tamil situation. I mean, the Tamil Nadu and India and so on. But if you just translate something from an English question answering benchmark to Tamil, that's not going to capture any of it, right? So there are issues with translation, but then right now that is what it is. Like it is all translated. Most of it is translated. So these benchmarks will not tell you to that minute detail about whether it is making an error on these kinds of like sandwich kind of issues or not. Yeah.
Okay, I have one more. That's more of an observation than a question. So you mentioned about Hindi and Marathi. Now I can probably see why that happens because the textbook literature in Marathi does not reflect the local vernacular language that's spoken. So that's the reason that might be happening because Marathi is type 0 of a language while Hindi is type 1. So that case, that gendered pronouns, that thing is almost
Right.
non-existent in Marathi. They use it very interchangeably. So
Yeah.
that could be one of the reasons it's going wrong. Another thing that I've seen is anything that you train, specifically Indian languages, if you train on South Indian languages, one language will not extrapolate to another one.
Right.
However, that does not hold true for a lot of North Indian languages like Gujarati, Marathi, Rajasthani language.
Yeah.
And I think a couple of other languages here, even the tribal ones, they translate pretty well.
Yeah.
So-
Right. That's right. So there are other issues with the Marathi Hindi thing, and that is that they follow the same script, right? And many of these models will treat them as the same language because you're just joining all the data together and training. But the subword, so this tokenizer actually breaks these into subwords, right? And the subword in Hindi and the subword in Marathi has a totally different meaning, right? Even though it looks the same. And because of this, for semantic tasks, we find that Hindi actually will bring down the performance of Marathi. But for other tasks which don't require this kind of information, they may actually help each other. So there is a lot of interference that is happening, positive and negative, when you suddenly introduce new data into your model. And again, without testing on everything, it's very hard to say what's happening in these models. So I think we are still at a very, very initial stage of understanding these models. So yeah, just want to make that clear that all of the hype is very unfounded.
Yeah, one last question. It's more of something that I want to ask you. Where can we access this tool that you just
Oh
demonstrated?
yeah, I flashed it on some slide. I can just Maybe we
You
can just
mentioned it's
have a
open
look.
source, so it's hosted on
Yes,
Git or
yes.
someplace.
Or you can just search for Litmus and Microsoft and you should be able to
Okay,
find it
okay,
online.
thank
It's
you.
there on GitHub and the demo is also there. So you can, and the paper is there as well. So you can just take a look.
Thank you so much.
Welcome.